Hello, I am Anthony Atkinson.
And I am Marco Riani.
We are going to talk today about some further analysis of data from our exciting new book about robust statistics, which we have written with three co-authors.
Aldo Corbellini, Domenico Perrotta, and Valentin Todorov.
So today's data are income from an Italian municipality. The response is income, but it comes from a sample of 200 subjects from a larger database and is of those with an income less than or equal to 50,000 euros a year. Boundary variable is age. Second is number of years of education, which runs up to completing MSc degrees. There's gender. There's a return from capital investments, which is called extra gain, and there is hours worked per week.
We start by loading the data and creating, as usual, a y-x plot in order to understand the basic features of this data. As expected, relationship with age. It's not so clear whether gender is significant or not. From this y-x plot, it is not so clear whether the data have to be transformed and then if there are some outlying observations. In chapter 1, we had concluded that the data had to be transformed.
When the data were just treated as responses without any explanatory variables.
Now we start with the no-robust fit. The adjusted R-square is very, very poor. Given that there are a lot of variables, not significant, it makes sense to run an automatic variable selection procedure. Standard automatic variable selection procedure says that age is the only one variable, although it is not quite significant at the 1% level. Now we want to understand whether the data have to be transformed. And this the fan plot. It's a bit peculiar, this fan plot. And notice that here we have also included the value of -2. Indeed, a bit strange for the income data to have a transformation parameter equal to -2. And from this plot, it comes out that at the end of the search, the trajectory start changing and then going outside the confidence bands. The only one which remains inside is -2. However, -2 has gone outside in previous steps of the search. Let us see if with our automatic procedure for transformation we can say something more.
The BIC suggests 1. That is the boundary that we're looking at in this search, and the other plot suggests a value of 0.5. A feature to which we would like to draw your attention is if we look at the fan plot, the trajectory for -2 seems to be behaving quite well towards the end of the search, although here, using the BIC, it is very firmly considered to be unsatisfactory.
Note that there is an agreement between the BIC and the agreement index, in the sense that -2 is the lowest confidence for both indexes. And notice that, in fact, the proportion of units that are used is much smaller than that of the other values of the transformation parameter. Now we trust the agreement index. We go on transforming the data using lambda equal to 0.5. That is the square root transformation. Transform the data and then we do the outlier detection procedure. The minimum regression residual goes out of the confidence bands, and now we find a lot of outliers.
These outliers are all for individuals with, or nearly all for individuals with higher incomes.
Then we do a monitoring plot of the residuals
from the square root transformation, and here we see that there are 36 outliers, and we can see that they all correspond to large residuals, large positive residuals.
And then when they enter, their residual tends to decrease. With the ANOVA in the transformed scale using all the observations. The adjusted R-square is 0.0286. Still all the variables are not significant apart from x1. And we also have the ANOVA in the transformed scale when the outliers have been removed. And notice now that the value of the adjusted R-square has changed dramatically. Now the value of adjusted R-square is 0.66, and there are many more significant explanatory variables. Now look at, for example, the significance of the t-statistics for x5. This was not significant at all in the original scale with all the outliers.
In fact, there is only one variable now that is not significant.
Now we have a QQ plot, which is our figure 10.17. You plot with the 99% simulation envelopes using all the data in the left-hand panel, or just the units not declared as outliers in the right-hand panel.
The plot on the screen here makes it quite clear that at the lower tail, the negative residuals are lying on the simulation envelope. In the plot in the book is so condensed that you can't see this. But there is certainly this is not exactly a nice straightish line between the simulation envelopes. So perhaps we haven't found all the structure.
Let us see now the monitoring of the added t-test. And now we go to figure 10.18. In the left-hand panel, you can see that when you consider all the data, there is a dramatic change in the value of the t-statistics for x1 and x5. These trajectories start to increase, and then when the outliers join the subset, they become non-significant, or they lie very close to the significance level.
Whereas, when we go to the right-hand panel, you can see that the trajectories for x1 and x5 increase steadily, but the other three variables just remain within the confidence band.
The value of x2 is at the end, very close to the rejection region. Now we do some variable selection in the transformed scale. We exclude the outliers, so our upper model is linear, and in this case we end up with the model with 4 significant explanatory variables. The adjusted R-square of the final model, which contains these 4 explanatory variables, is 0.66. On the other end, if the upper model is quadratic, we have also an interaction term between location and the number
has worked.
Although this is marginally significant.
It also has a rather disappointing sign in that it is negative. We would hope that education and work would increase income, and in fact they do, but what is happening here is the interaction is negative because the increase of the two variables together is not quite as much as would be expected if they were independent.
Now we move to the non-parametric analysis. We have our automatic procedure for finding the best options. The output from the analysis says that the first 2 solutions have a correlation which is 1, therefore are exactly the same thing, and also the correlation with solution 3 or solution 4 is very, very high. Notice that in all those 4 solutions, robustness is present. This means that this option must be included. You must have a robust analysis. Let us see now the usual output plot from Revas using our best model.
These plots both have some interesting features. The first one in the left-hand plot is that transformed income is virtually a linear function of income, so it looks as if using Revas you do not have to transform the response. The 2 residual plots appear to be perfectly well behaved. If we go over
it is interesting to notice that both the parametric and the non-parametric approach agree with the number of outliers, that there is indeed a group of outlying observations.
What do we have right here? We have 33, is that right? And in the parametric analysis, we had, I think, 36.
Now, let us move to the interpretation of the transformation of the explanatory variables.
The crucial point about this is that x3 and particularly x4 are not significant, so we do not have to try to interpret this peculiar squiggly line that is for extra income. Age clearly has a positive increase on the amount earned. Education has a positive increase, and hours worked also have a positive increase. Gender is not significant at this income level.
This non-parametric transformation of the explanatory variable enables you to understand what is the portion in the X space for which the relationship tends to remain constant and from which point the relationship increases. So this gives an additional interpretation.
Right.
Conclusion of the analysis of this example.
I think it's very interesting that the regression analysis involving decisions about transformations and the significance of variables and the semi-automatic procedure of variables give very similar results and so are mutually supportive.
Thank you for watching.
Yes.
And
thank you for your attention.
see you to the next video.